Before we move on to our topic, let me introduce what is meant by wireless communication system. It is a method where information was transmitted like voice, data or video using a medium between two or more devices without using cable or wire. Instead of it used electromagnetic waves such as radio wave, infrared or microwave to send a signal through the air over the distance that can range from a few centimeters to thousands of kilometers. These systems are essential for modern technology like now to provide convenience, mobility through applications like cell phone, Wi-Fi, GPS, Bluetooth, cellular network and so on.
We have three objectives. So the first one is mobility and flexibility to allow users and devices to communicate and access information from virtually anywhere. Second, scalability, make it easy to expand a network by adding more devices or extending coverage without the need for extensive physical cabling. Third, reliability, provide a communication system that is less vulnerable to damage from physical disruption such as cable being destroyed.
What is Wi-Fi or wireless connectivity and how it works? Back then, all information transferred through wire, so it was very messy. We had enough with cable management and make Wi-Fi. Wi-Fi using radio wave. It's kinda like light. Unlike visible light, radio waves are low and invisible. It means it can pass through wall with ease, making them perfect for connecting devices wireless. First, your phone sends a request. Then, the request broken into small pieces called data pack. This pack already in binary in 1 and 0. The binary will transfer into wave frequency. Wi-Fi signal operate using radio wave, and the speed of this wave measured in gigahertz. 2.4 gigahertz. It has a longer wave, it travels farther, it passes through wall better, but it's slower. 5 gigahertz. It is faster, it supports higher data speed, but it doesn't travel as far.
In conclusion, Wi-Fi is the greatest thing ever made.
So next is Bluetooth. We have 3 points. First one is short range radio wave. Bluetooth also uses radio wave around 2.4 Hz but only for short distance, usually less than 10 meters. It's designed for low power use, which is great for headphone, speaker, keyboard and smartwatches. It lets device communicate without cable. So second, connect device nearby. The technology is designed specifically for short range communication and typically around 10 meters. Through some device can reach up to 100 meters. Second, low power usage. Device spend most of their time in low power mode, which is like sleep mode, and only wake up for short period to transmit or receive data when an event occurs.
This slide shows how 5G is changing wireless communication. It provides faster speeds, so downloading and streaming are much more smoother. It also has low latency, which reduces delay and makes real-time activities like gaming and video calls better. Lastly, it has higher capacity, meaning more devices can connect at once, supporting smart homes and smart cities. Overall, 5G makes communication faster, smarter, and much more reliable.
Satellite communications. What is satellite? Satellite communication is a wireless communication system that uses artificial satellite in space to transmit and receive signals between different points on Earth. How it works. At the ground station on Earth, an uplink transmits the desired signal to the satellite transponder. At the transported satellite, it amplifies the incoming signal and changes the frequency. The satellite transporter transmits the signal back to downlink Earth station and the ground equipment receives the signal. 3 satellites of orbit is GEO, MEO and LEO. GEO, or we known as geostationary Earth orbit, is the farthest from Earth, about 35,000 kilometers away. Because it stays in one fixed position, it can cover a very large area. It is mainly used for TV broadcasting and weather monitoring, but it has medium delay and it is very expensive to set up. MEO, or we know as medium Earth orbit, it is located between GEO and LEO. It has lower delay compared to GEO and it is commonly used for communication and GPS system such as navigation. Lastly, LEO or low Earth orbit, it is the closest to Earth. It has the lowest delay and fastest connection, which makes it suitable for satellite internet, remote sensing and space mission. However, it needs many satellites to provide full coverage. Just the lower the orbit, the faster the connection, but more satellites are needed. Satellites are very important in our daily life. They are used for TV, broadcasting, sending channels like Astro to our home. They help with GPS navigation for apps like Google Maps and for ship and airplanes. Satellites also provide internet in rural areas such as Starlink. They are used for weather monitoring to track storm and climate. During disaster, they support emergency communication when towers stop working, and they also help in global communication around the world. We know that satellites offer many advantages to us as a human. They provide very wide coverage to us to stay connected with our friends, family members, and global. We also know that they can operate without ground infrastructure and are reliable in remote or rural areas. However, they also have disadvantages, which is weather condition can affect the signal quality because of the thunderstorm, raining, and so on, and the cost to build and launch the satellite is very high. Therefore, while satellites are extremely useful, they also come with certain limitations.
Today, I would like to talk about Global Positioning System, or also known as GPS. It's a satellite-based wireless communication and navigation system used to determine your exact location anywhere on Earth.
So how GPS works? GPS is made up of three main segments: display segment, the control segment, and the user segments. First, the satellites orbiting Earth send signals that include their position and time. Next, ground station shown at the bottom track these satellites and make sure they stay accurate. Finally, the GPS receiver picks up signals from several satellites. By comparing the signals, it calculates the exact location. In simple terms, satellites send data, ground station maintain the system, and the receiver uses the signals to find where you are. Key features of GPS: first, high accuracy, as low as 1 until 5 meters, better with differential systems, free to use, works in all weather conditions, provide navigation, timing synchronization, and position tracking. Now, let's look at the application of GPS tracking as shown in this image. First, logistics. GPS helps companies monitor the real-time location and route history of their vehicles, improving fleet management. Municipal departments can track each vehicle, such as garbage trucks or service vehicles, on a single platform. GPS allows rental services to calculate distance travel and ensure accurate billing for customers. In constructions, GPS tracking helps provide quick maintenance support in case a machine breaks down. Drone use GPS to maintain accurate routes and trigger alerts whenever the device goes out of range. For delivery services, GPS provides detailed reports on delivery time and route efficiency. Overall, GPS tracking brings visibility, accuracy, and control across many industries. The examples of GPS is Google Maps or Apple Maps navigation, food delivery apps such as GrabFood, Foodpanda, and Shopee Foods, next fitness trackers and smartwatches, vehicle navigation systems, and also emergency services. In conclusion, wireless communication systems like Wi-Fi, Bluetooth, cellular networks, satellite communication, and GPS have become an essential part of modern life, enabling fast, flexible, and efficient transfer of information without the need for physical connections. By using electromagnetic waves, these systems support a wide range of applications, from mobile phones and Wi-Fi networks to satellite services and Bluetooth devices. Although challenges such as interference, limited bandwidth, and security concerns exist, continuous advancements in technology are making wireless communication more reliable, faster, and more secure. Overall, wireless systems play a vital role in global connectivity and will continue to shape the future of communication.